Hello everybody. This is now a re-recording of my farewell lecture, Models in Sciences, Engineering and Daily Life, given at December 7th, 2020 at Lappeenranta University of Technology. At the same time, it was also my farewell lecture for Christian-Albrechts-University, Kiel in Germany, since I'm now retired. So my main message is models are instruments that are used for all human activities in all sciences, in all branches of engineering. That means in this case, models are essentially our fourth dimension of human activities. Before starting this whole course, I would like to convince you that a model is nothing else as a well-formed, adequate and dependable instrument. Instrument is especially important, and a model represents origins. And the main thing as an instrument, it functions in utilization scenarios. For this reason, a model should be adequate. It should be also dependable. And dependable means especially it should be justified and of a sufficient quality. This notion is not only my notion, it is also a notion that we have been representing in the Wissenschaft und Kunst der Modellierung compendium that we have been developing some time ago with my colleagues in Kiel from different scientific disciplines. Of course, I should also state what is not contained in this lecture. And this is mainly related to my background. My background is mainly database, a bit of mathematics, and of course a lot of experience I gained in conferences. I show you some of these books I have been editing or writing. I have also given a number of videos. You have in the YouTube channel Bernhard Thalheim or in vk.com video channels that show what is the theory, technology, pragmatics of modeling. You have the open summer school lectures before ER 2020. You have also the podcast of business informatics, and now you will get my belief that models are the fourth dimension of human activities. I haven't been writing a number of papers, and for this reason I am restricted to my insights into a theory, culture and science of modeling. My first claim is models are everywhere. Really everywhere? Models in sciences, engineering and daily life, really everywhere? I think we should maybe look into different application cases, and we will discover that there is an inner logics. We know a good number of different models. Models for representation, models for instance for some kind of description of systems, models of perception, conceptual models, and also prescription, explanation, guidance, and so on, models that are somehow maybe different stereotypes of the same form of a model. That means in this case we should have the general notion in mind and specialize according to the needs we have really in mind for modeling. Let's now look for case studies. First of all, I go to my area, the computer science. Models are used, for instance, in the database development area for prescription and also for description. Description means, in this case, we might use also conceptualizations. That means in this case, we have also a conceptual model. And a model is then maybe something what is delivered in an understandable, formalized, maybe very rich, conceptually enriched. And in this case, it is somehow acceptable. Models are also used for prescription, especially for prescription of conceptual models as a blueprint for coding. In this case, our model understanding inherits the technology, the mental and computing device models we have been using as a basement for our development. Models in engineering can be also used for guiding us. Let me take the very simple and very nice beer brewer example you can find in Egyptian pyramids that shows a prototypically, somehow based, essential situation. Beer brewing is of course a technology case, it's an engineering case, and in this case we inherit again the practice, the flow of work and the essentials of this flow of works in our models. Models can also be used for orientation. Let's use it from the area of Egyptology. You have maybe these very nice barks, let's say of Tutankhamun or of, from the Valley of the Kings. These are models for the afterlife. You have, however, also, let's say, barks that can be somehow given or displayed outside. Are these models? Maybe these are not models. That in this case we inherit ancient culture and thoughts from that time. That means in this case we might have also to have criteria that a model or something is not a model. A thought or maybe a thing is not really a model. Models can also be used as playground models. Let's take the case in medicine. Let's say we would like to know what is the reason that we have some kind of heart insufficiency. In this case, typically we are measuring our heartbeat. We have maybe this kind of electrocardiogram, or we have the behavior of our valves, maybe in the left or maybe also in the right heart. We have a very simple understanding of a model for the heart as a sucking and forcing pump based on this kind of pumping mechanism. But this is a very primitive model. We can also have a bit more abstract but more refined models as abstract and coarse diagrams. The funny thing is, however, sometimes we need models that display the essentials. And in this case we might use this kind of general display by, let's say, an electrical or electronic circuit. So in this case we use models for investigation, for inspiration, for variation, for playing with parameters, and in this case the model is in reality a playground model. We might use also models for explanation. Take a very simple example, the hypothesis that the global minima can be characterized by the local minima. This was an hypothesis we have had in the 19th century. Peano gave a counter-example on the basis of a formula. I think it is very difficult to understand this formula. However, if you use some kind of, let's say, informative model, then in this case you might have this very nice figure here. This very nice figure uses a scaling factor, uses special P and Q, and then you have a good display. You can use also what is given, for instance, the Wolfram website. Then in this case you don't see really that the local minima don't characterize the global minima. You have also other, let's say, geometrical visualization models. Maybe some of the models are not really very nice in order to reason about this hypothesis. In all cases, however, we inherit theories. But we should be careful. Maybe we have to consider also for whom, in which form we are giving models. Another kind of models is what we meet in daily life. You see, for instance, this very nice picture from a temple in Japan. And in this case, you know, oh my goodness, this is now maybe something that is directly communicated Or you see maybe the Saint Bernard picture as a martyr, and in this case you know, oh my goodness, I should be careful, I should be a bit more, let's say, considering my environment. That means in this case we can use also models for communication. It is in this case implicit, it is based on our culture, and we use in this case some sign language. For instance, you say here in this case, oh my goodness, this could be, let's say, the typical picture of fruits we meet in fall. Models can also be complete stories or parables or analogies, how you read them in the Bible or in other holy books. They inspire our thoughts, they orientate, and maybe they represent a very complex field. Think about this picture around the corner from Lappeenranta, from Paulus Porter, given in or displayed in the Hermitage in St. Petersburg. And then you see here the punishment of a hunter. The hunter is hunting animals, and later the animals decide, no, that is not the right way. For this reason, the hunter is now going to be captured. And since the hunter cannot be hanged, instead of the hunter, his dog is going to be hanged as the punishment of the hunter. That means in this case, a model reflects, inspires, orientates us. We can also use models for investigative reasoning. For instance, in archaeology, we display our situation, what we have, what we think we could have. We have a number of conceptions, like what is a settlement, what is a house. We have some kind of understanding for time, and then we use some kind of theories. In some cases, these theories are called middle-range theories, but essentially they are only models. And then we have a number of investigation scenarios. Then in this case, we use a number of models, a model suite that is generalizing and systematizing middle-range theories and allows us to mediate between quality and quantity. That means between data and theories. Models can also be used for steering us. Let's say we can think, what is really search? We know so far, at least in computer science, we implemented 7 different kinds of search. One is zapping, and the best one is, of course, direct querying based on an SQL query. Then we say, okay, fine. In this case, we first of all initialize our search request. That means we develop the search landscape. Then we look for general stereotypes for searching. Then we look for pattern, and then we can have a direct expression by extract, transform, load requests, and finally we get the result. That means in this case we inherit a typical mold and method. That is the same what we do in mathematics. In mathematics we also inherit the mold for solving differential equations, at least for the analytical or for the numerical solution. Models can also be used to somehow to inform us. Think about the chair in the middle of this picture. This chair is of course not in general a model. It is, however, a model in an exhibition. Then it substitutes, it reflects, replaces, deputes what is a chair, what we can buy maybe later when we go to the corresponding shop. Or the models can be used for the negotiation with customers. For instance, this example of the door that is also taken from the Hermitage is nothing else as a negotiation model for the church customer. That means models inform us, accept us, become acknowledged. We can buy, trust, and understand what we have gained so far. Models in this case are very old. In ancient Egypt, we found such kind of house models showing us what is the structure of a house you can maybe have in Egypt 4,000 years ago. Yeah, now we have a problem. Are models necessarily based on ontologies? An ontology determines what exists and what is not. Maybe it uses a well-defined language. Do we need really a language? Sometimes we have conscious, subconscious models, and we maybe don't use a language. Sometimes we have impressions. If you read Hanover 1945, then you have an impression what is on that picture displayed. It is, of course, not Hanover on the 1st of January 1945, but in late May. Or you have the classical clock of Antikythera. That is a model, and the language is a very complex thing. That means in this case, models are instruments that are used beside native languages already. That means in this case we have also things that are models and completely different from our classical computer science understanding of models. That means in this case, for instance, you have as a usual joke, a fashion model is a model. It is even a bit problematic model. Of course it shows what kind of clothes you can buy, but it shows also some kind of culture. It shows also some kind of behavioral pattern and understanding in which the fashion show is embedded. Models can also be used to form, maybe as a form for production. You have it in the inverted form or in the positive form. Models of a mother and a father are developed before a newborn child can say mother and father. And later you realize that the model of your mother as a helicopter mother is completely different from the model of a mother by your friends. That means in this case, models might also be completely independent from the language. Okay, let's now summarize the lessons we have gained so far. Models are instruments. That is a bit of difference to the classical model theory that can be and are used on purpose. Models have origins, whatever it is, our thoughts or real material objects we see. They are reflected and inherited, and of course, typically a model represents a number of origins. Models should somehow be analogous. Maybe we should not imagine that we have some kind of mapping. Think about the mother model. Models should be well-formed, beautiful, attractive. Models can be language-based, but in this case we inherit all the drawbacks of language. Models should be somehow simpler. Maybe we should support parsimony, since we select models by focusing on essential things we would like to consider. Instruments needs, of course, trust and justification. Models also inherit deep thoughts. What is behind the model? What is based on that? Models can also be based on molds. That means on meta or macro models that are the sources for success stories. Model consistency is not really the issue. The most important issue is, however, some kind of quality, for instance, coherence. And we realize that models are our first instrument before we can use a language. Oh my goodness. Then we can think of 1001 notions. So far I know only 800, maybe in 2 years from now I know 1001 notion. Is there something common? Maybe we should generalize the theory of models in a proper form. Okay, let us consider first of all why we use models. We use models because we are humans. That means we have a restricted focus, a restricted mind, a restricted computational facility, and for this reason we would like to have things a little bit simpler but understandable and useful. Therefore, we orient our thoughts, our behavior on separation of concern. We would like to concentrate. That should be convenient, and of course we would like to avoid information overflow or, let's say, forbidden areas. Forces are, in this case, it's data, our biases, our deep models behind, so we should consider these deep models, the interpretation, the origin's complexity, the hidden aspects or the shadows. As I was showing in the beginning with the model notion, we have been using here, we have in our models some kind of deep stuff, that is the green part here, and we have maybe something what forces us to models, that are utilization stories, utilization scenarios or spectra, where the model are functioning as instruments in these scenarios. Models represent origins. We have a profile. We have a community of practice that loves these models. That means in this case we have now a good number of very different models we should consider. And of course we would like to avoid the complexity of the origins. We would like to show also maybe what we really need to display and hide the rest. And we would like to use it for quick, fast, efficient understanding, usage as an instrument. Okay, can we in this case go with what has been done in the past? Herr Stachowiak has been trying to settle or to define the notion of a model, and he struggled a lot. And one of his notions is a model should be based on a mapping property, should be based on an abstraction or truncation property, and should be based on a pragmatic property. Based on our examples, we realize, however, mapping is a little bit too restrictive. We should have analogy. Truncation, abstraction is not the right property. We should focus. And pragmatic means in this case a model should function, it should be purposeful. That means in this case, whenever we want to develop a proper understanding of models, we should have what comes with a model within the disciplinary context. What tells us the background, the grounding and the basis? What kind of community of practice we are using? Do we need a justification in order to trust? Oh, that means we should believe, rely on a model. And of course we appreciate beautiful models. Let's say they should be well formed. That means in this case the representation matters. And of course also the quality matters. It should be of a sufficient, not of a perfect, most optimal quality. It should be of a sufficient quality. And of course we can somehow compromise among quality characteristics. So far we know maybe 1001 different model notions. A model is a mathematical description of a business problem. Or Roland Kaschek's notion. A model can be simply considered to be a material or virtual artifact which is called model within a community of practice based on a judgment of appropriateness for representation of other things and serving a purpose within this community. That means we have a good number of different notions, and if we would like to have now a general notion, that we should maybe target on a notion that is general but can be somehow specialized to any of these 1001 different model notions. In this case we use now a general notion. A model is a well-formed instrument that is for origins, for a number of origins, for a set of origins, for a collection of origins. Adequate, that is what everybody tells us, and dependable. Adequacy means in this case it should be analogous, focused and purposeful. What we hide differently in different disciplines is a model should also be dependable. That means it should be justified and it should be of a sufficient quality, and we are able to reason on this sufficient quality. Justification means in this case it should be corroborated, it should be coherent and conform to our criteria, to our ways of reasoning or using the thing. It should be falsifiable or validatable, maybe better. It should of course be stable against changes in the collection of origins. And additionally, a model that is used as an instrument has a background that is typically not told us, and the background forms some kind of deep understanding behind. It means a deep model. We have a grounding and we have a basis. And we have also in this case directives for the direct consideration of models. That is a function, the set of also collection of origins, the context, the community of practice, and in this case models should function. That is now a very general notion. I think we should explain and explore it a little bit more in detail. In this case we have again our model house. In this case we say, okay, fine, the green part is a deep model behind, the intrinsic grounding that is not at all in question, our methods for using the model, and our context. The application of the utilization scenarios drive us to use a model. And for this reason we should consider this kind of utilization scenarios together with the community of practice. That means we have intrinsic and extrinsic part in the model. And a model represents origins, is based on the function or the purpose or the goals we have in mind, and in this case a model is appropriate as an instrument. In this case, one of the main properties is that the model should be adequate. Adequate means in this case it should be analogous, it should be more focused, it should be sufficient for the purpose. And of course, I think we should only consider models that are nice. And in this case, we realize that a model is nothing else as an instrument that is somehow well formed and well done. It means it satisfies a well-formedness criterion. Dependability means a little bit more. We have to have some kind of justification. Why the hell we are using this model and not something else? It means we should have some kind of corroboration, some kind of explanatory statement why we are using this model. Maybe in an implicit form, but anyway we should use it somehow. It should be rational coherent. It should be also validatable and plastic and stable. The second part of dependability is a quality criterion. It should be sufficient for the function in which we want to use the model. That means in this case we should have some kind of quality statement. In software engineering we have learned that we can somehow characterize or categorize quality characteristics into three kinds: internal quality, external quality, quality in use. And we should be able to reason about these qualities. That means we should have some kind of evaluation procedure. The evaluation procedure tells us how these quality criteria we consider as the essential ones can be directly somehow used for an explanation why we are using this model. That means in this case we have now dependability based on justification and based on some sufficiency of our quality characteristics we have in mind. Then we can consider very different utilization scenarios. I think everybody of you know Faust's last words, or the words about the word or the logos. The logos has essentially 6 different meanings. It is of course a word. It is of course some kind of judgment, of a concept, of what we have in mind, what we can use, what we are really using, and reasoning about the success of our using. That is coming already from old thoughts developed by Heraclit. In this case we have now a number of different scenarios. I would say 6 different scenarios. We use it for perception, we use it for concordance, acceptance, for judgment, we use it for comprehension, we use it for understanding and sense making, or for applying in a well organized form. That means in this case we have a number of utilization scenarios that can be used to characterize in which case we are using a good model. That means in this case, a model is nothing else as a special instrument. As such, it has a means. It is used in that way, that for which it is designed, in a maybe good, precise way, and we can achieve an effect, a result, applying this model. An instrument can also be used in several functions in a scenario. But essentially, a model is nothing else as an instrument. It can be a thought instrument, it can be also a material instrument. But anyway, the quality of the instrument determines its utility, usage, usability, and usefulness. Okay, there is a very famous saying, all models are wrong, but some are useful. George Edward Pelham Box is mostly cited in this way. The story is a little bit more sophisticated. He has been considering in this paper. But in this case, the statement is still true. A model should not be consistent, should not be true, depending on which kind of truth you are preferring. A model should only be useful as an instrument. But as such, it comes with biases, with beliefs, with paradigms, with postulates, with culture, with theories behind. That means we have some hidden background and hidden agenda and some assumptions. Models might be language-based, and in this case, the language matters. And the concepts we are using are really somehow the background that we should have in mind. In this case, we have a school of thought, some thought style, some pattern, some common sense we are using. And in this case, we are using our instrument in a special way. That means we have some kind of guideline or methodology. And we scope, focus, and orient in a certain way. That means in this case, a model comes already laden with a number of assumptions, with a number of background, laden essentially by anything what is coming with a deep model and with a utilization methodology. That means in this case with a mold. We have a tacit knowledge and the technology in our instruments incorporated, and that comes also with our models. So in this case, we have now two sides of an instrument. One is reflecting origins, having some kind of informative model behind, let's call it cargo, and then in this case, it reflects the origin. From the other side, it is used as an instrument for obtaining results in this instrument application. We might have supporters and enablers in order to achieve the result. That means in this case, we have now also a criterion for the model being of instrument. It should properly reflect what is in the origins, and it should allow us to derive, to anticipate the results of the instrument application. Let's consider it for a very simple example. Let's go to hemodynamics. In this case, we have supporters. That is our knowledge we have. For instance, for hemodynamics, you have maybe advanced concepts in volume, pressure analysis of the human heart. We inherit whatever has been developed in the past. We have an enabling panel that allows us to learn, to teach, maybe also to investigate our equipment. And in this case, we learn via the model or investigate what properties we have with our heart. In this case, we have now the model as an instrument is, of course, based on the application. That means in this case, our application is we would like to know what kind of parameters are influencing insufficiency of the human heart. That means we go now with human heart potential for certain, and in this case we would like to have some kind of investigating or investigative hypothesis consideration. Then in this case, our model has a function. We would like to detect dependencies. that is based on a behavior space. And the behavior space in this case is based on, let's say, a number of parameters. And then we would like to say, okay, fine, the dependency detection leads us directly to some kind of reasoning on behavior traces. In this case, we might use a model for investigation and explanation. Let's say the electrical circuit model. Of course, this model is based on heart models, on volume pressure models, and on other models we can have in, let's say, medicine. And what we would like to have as a result of this electrical circuit model is nothing else as behavior diagrams for reasoning. Okay, that leads us directly maybe to some kind of systematics, and also allows us to state what is not yet a model, what is a model. That means in this case we consider models as instruments that are prepared for use with some utility, capacity and potential. Okay, the central property we have already detected is a model has a function. For instance, for easy explanation. You see here this very nice picture displayed in Japanese restaurants showing you what you can get paying a certain price. That is an easy explanation of the food, of the menu. You have also easy explanation through, let's say, some geometrical models. You can use models for communication, for fault prevention, like here in the NARA case. Or you have models used for system constructions, or for explanation, for blueprint, for reconstruction and illustration. The central property is in this case a model functions. And then in this case we should consider which functions a model should have. And now we can say, okay, fine, we can now refine this Heraclit 6 dimensions to essentially 4 different aspects of models. One is a model is used for problem solving, whatever the problem is. A model can also be used to explain, somehow to display, to depute scientific reasoning, or it is used in a social setting, or it is used for applying the model. So in this case we have now very different scenarios, and the model comes with a part of these scenarios that are supported and another part that is not supported. Models for reflection, for problem solving, or models for engineering as a guideline, or models for learning, for comprehension, for intellectual absorption, or models that are coming like our orientation models with some kind of social dimension, acceptance, internalization, concordance. That means in this case we are orienting our model on interaction. Then in this case, for instance, we can now say, okay, fine, what are typical scenarios? One of the classical typical scenarios for models is the communication scenario. We have a sender, we have a receiver. We have a sender-receiver relationship so that the receiver might have the ability to understand the sender, and then the sender sends a model. Of course, based on his explicit background, on the experience in culture, and the same is also valid for the receiver. That means in a communication scenario, the model is used for transmission, for maybe exchange of information, maybe in order to represent, express ideas in an effective way. We can use it in debates, we can use it in other communication scenarios. Then a model has now the function to be a means, a mediator for communication. We have a good number of other scenarios. One is negotiation, that is a little bit based on the communication scenario. Or we can use it for learning scenarios, for description scenarios, or for maybe construction scenarios, or for conceptualization, documentation. That means in this case we have a number of different scenarios, and in each of these scenarios the model functions. That means we can characterize now the scenario and the function. And then we come to specific notions of a model. There's a general claim. Model theory in mathematical logics is completely different from models in other disciplines, scientific disciplines, or in engineering. That is not true. We can maybe somehow display what a model is orienting on 6 dimensions. One is the community of practice, the other is the context, a third one is the methodology, the application, a fourth one is maybe the tools and techniques we are using. We base our models in any case on a context. We have the origins, and a model reflects whatever is somehow within these 5 different dimensions. That is the same for mathematical logics. However, in this case we say, okay, fine, community of practice, everybody. So it is not of interest. We use now for our context knowledge. Let's say our axiomatic system. And we add a little bit of statements about our little world we consider. And in this case, models are instantiations showing us what is in our little knowledge and little world based on logical methodologies and on the calculus we are using. That means in this case, if we are not really careful, let's say if we don't add, for instance, Archimedes' law, then in this case we get for this kind of little statement also a model that is a little bit more difficult to understand, namely the Robinson numbers. That means in this case, however, we learn that mathematical logics and models in other sciences are essentially the same. Okay, then we come now to some way to distinguish a model or an instrument that is not yet a model from the real model. A model should function. It should function well, optimally, flawlessly, properly. A model might have several functions, and for each of these functions we might have to characterize why this instrument is a model. The functions can be characterized. Functions can have various grades of maturation, and the maturity level depends on the model objectives. Functioning can only be defined for specified scenarios. For this reason we need to know the scenarios first, and then we can reason about functioning, and then we can reason about the instrument being, and then we can reason about the model being. Models should have the required adequacy and dependability. And we have a number of typical functions we can consider in all these scenarios. For instance, for engineering, we have a blueprint. For realization, we have a starting point, prescription, a mold, a guide, a companion, and so on. That means in this case we have some kind of demarcation ability. Demarcation in this case means it is a characterization of the model function, and that determines the model being. It should be sufficient, it should be adequate, it should fulfill our expectation, it should be fit, it should conform to our restrictions, and of course it should provide and supply what is desired or needed. That means in this case we should ask what should be modeled and what can be left out, how many views we can have to take to the system, how many individual models we should consider, and in this case of course we should also say what is left out, what is not really represented, which gaps are still there, and what is the obstinacy of a model. And a model should be of use for a community of practice. That means in this case we can say, okay, fine, in which case something is of no use for the community of practice. The community of practice comes with a certain culture, a certain reasoning schema. It should be also fit as an instrument in these scenarios. That means in this case our community of practice determines in which case we can accept something, an instrument, as a model. A model should be as simple as possible, it should be somehow supporting at least parsimony. For this reason we should avoid over-totalization or manierism. We can base our model on the deep parts, that means we have a foundation. We can have a high dynamics in the collection of our origins. For this reason a model should be also very flexible. We can have a heterogeneity, and of course sometimes we need a model in a very sophisticated way with very sophisticated tools. Okay, our community of practice now is a second way how to determine what is a non-instrument and what is a non-model. And then we have, of course, a little trick. We should inherit whatever is inheritable. That means we are systematically reusing, integrating, I would say cannibalizing the conception spaces of our origins. And then we integrate whatever is known from our origins, whatever is given as an enabler like language. And then in this case we can directly inherit, of course, based on our understanding, based on what we see in the positivistic manner, like I show here with the little display on the analogy of the cave by Platon. We can inherit whatever is possible. That means in this case we have now a way for the development or for the utilization of models. Okay, then we realize now our models should be really usable in a very effective form. And since we are humans, we are very restricted in our abilities, in our memory, in our observation abilities, for instance. So in this case it should be parsimonic. That means in this case we might have to think whether we have stereotypes, frames, whether we can inherit whatever has been done in the past. That means in this case we come with a model is what we see on the surface, what we consider on the surface, and what we have anyway in our background. This is nothing else as some kind of iceberg notion. We have what is easy to see, and we have what is difficult to see. That goes back to cultural reasoning, or the reasoning about cultures, and modeling in this case is mainly on the easy to see part, and we inherit the difficult to see part. That means in this case we inherit a deep model that consists of the grounding for modeling, of the outer directives, context and community of practice, that uses a specific, maybe negotiable basis, assumptions, general concepts, basis, practices, languages as a carrier, and so on. And it comes also with some kind of utilization schema. We would call it disciplinary matrix that consists of the deep model and the modeling mode. This gives us a possibility to have a modeling frame setting. A model frame is given by the model landscape, with scenarios, with functions of the model, and it comes with a matrix. The matrix is nothing else as the deep model, the context, our general understanding of the community of practice, and the mold, methodology, and especially the methods we can use. That they can be used for stereotyping and categorizing models in a proper way. And based on this, we have now a model as an instrument combines the deep model with a matrix in the landscape, with a normal model that reflects the origins we see or have in mind, that reflects somehow the disputable basis, and of course the supporting techniques we are using in this case. And it is of course based on some kind of beautifulness, that means well-formedness, and in this case it becomes adequate and dependable according to the criteria I have been giving here. And all these are now parameters for the model being and parameters for the model development. The deep model is a very convenient tool. For deep models, we consider the context, the community of practice, the methodology, and the mold. The origins are considered for the normal model. That means in this case we inherit whatever is given the deep model, and we are lazy, only what we have in our origins sets. And then we represent it by models. In most cases, however, by a model suite. I will come to this notion in a minute. That means in this case, we would like to have a deep model that is stable, that tells us what is there, and we have a model matrix that is somehow developing anything in a proper fashion. And the deep model is nothing else as our background. We should, however, restrict ourselves a little bit with the deep model. In this case, the deep model strikes through. That means in this case, a model has some kind of obstinacy. Model building is not a mere illustration of thought, but enables the mind to explore and find new structures that may otherwise not appear out of imaginative processes, Wilkins stated. That means in this case we have something that comes with and strikes through from our deep model. In this case we have some kind of obstinacy of models and of modeling languages especially. That is well known in architecture. Think about the Olympia Stadium in Berlin. It has a pretty funny form, but if you know that the model for this stadium was built in sand, then you know why this structure came out. That means in this case a model comes with some inner structure, and in this case the languages we are using are striking through. In a similar form we have this for conceptual models. In a recent paper with Heinrich Meyer we describe the triptych of conceptual modeling. You find here the references, and we define that a conceptual model is a concise and purposeful consolidation of a set of concepts that are presented by means of terms in a predefined linguistic format. As such, it establishes a view of a given notion space. Okay, so in this case we have now something like adequacy that comes somehow based on the analogy, based on the focus, based on the purpose. We have dependability, and then we can define a conceptual model is now nothing else as a model that is enhanced by conceptions or concepts from a conception space, is in our area in engineering, in most sciences, formulated in a language that allows well-structured formulations. It's based on a mental perception situation models with their embedded conceptions and oriented on a matrix that is commonly accepted. The world we consider for models is now our world. We use our languages, our thoughts as enablers. We observe situations. We have some kind of imaginations and fantasy. And we have, of course, also some kind of supporting things. That is our thoughts, also our encyclopedia. And this is coming with a classical semiotic triangle, often referred to Ogden and Richards. In reality, it should be referred to Aristoteles, or Bolzano, or Twardowski, or the Husserl, representing what we have in our worlds. And the model is now the second dimension. Based on that, we use now our modeling world for the reflection of the situations, of the enabler, of the supporters. And in this case, a model is now nothing else as maybe a means to reflect what we have seen in our worlds. Then in this case, we use it for communication, for specifying, for sense making, for systematizing, synthesizing, organizing, and ordering what we see in our worlds. That means models come as a second perspective dimension over our world. The modeling world is now some kind of reflection. And additionally, the science world is now rounding up all this. Rounding up in order to have some kind of integration of our thoughts, of our worlds, and what we can use so far as a supporter. That means in this case, models are, of course, for science, of course, for our world reflection, and as a third one, for our engineering. Models at science are used for comprehension, for conceptualization, for absorption. That means in this case, we go now from the third, the science dimension, down to the second dimension, the modeling world, as something that is reflecting, reasoning instrument, surrogating, learning means, illustration, demonstration, informative companion, guide, elaboration, support, mediator in our sciences. The fourth dimension is engineering. Models for engineering are used in order to have some kind of good tool for the development of our results of engineering. They are used for inspiration, for guiding, molding, manufacturing, blueprint, companion, and. That means that is the classical way how we are using models in computer engineering, or sometimes stated in computer science. We have a good number of engineering functions for representation, engineering, mastering, technology for conceptualization, for theoretization, for orientation, for collaboration, for reflection. In this case, we can now say, okay, fine. Greenfield development of models is nothing else as we consider the worlds, and then we consider for our community of practice the modeling worlds with the concepts. That is a typical development of models in daily life, in science and engineering, as a greenfield development. Greenfield development is development of models from the model worlds side. My dream would be, in this case, however, that we use not only models for programming, as we do so far, we should step towards modeling to program. There is nothing else as model-based development and reasoning. We see it already, and this will become an art instead of only a communication instrument. In future, I would like to have modeling as programming. That means in this case, we master our development of programs as a technology based on models. And finally, we should come up to a modeling culture. Models are used as a program. We considered so far greenfield development, but we should also consider brownfield development. In brownfield development, we have our models, but the world has changed. In this case, we develop some kind of change to the model. And in this case, the model will have maybe also a journey of different functions that it plays in different scenarios. That means in this case, the journey of a model might reflect the whole story of usage of an instrument. And in this case, we need, of course, a systematic change management. In this case, we need also some kind of maintenance and retirement management. In this case, we are using also models as a model suite. A model suite is nothing else as a good number of models for which we know how they are harmonizable or how they are associated. In the technical means, we say, okay, fine, there should be a controller, a tracer that allows us to handle this model collection. And then we apply and deploy a number of models in a coherent, consistent form. We might even consider that is one model consisting of several submodels. Then in this case, a model has an inner architecture, maybe consisting of a number of different models. In this case, it is supporting different ways how to structure things. Okay, let us now only show that we can have also some kind of theory of models. I would like to refer to my lecture 18 in the modeling to model lectures at YouTube and VK, but I would like to show at least that there is some kind of theoretical background. Is there we should ask ourselves, is there a theoretical background for adequacy, dependability, systematics, reasoning that we can use for proofs, adaptation, deployment of models? That is a really heavy program, and I think this is a program for the next, let's say, 5 decades. In this case, we should go with the ladder I have been using already for the models as programs, or model as a program. We use models for the daily life, with our daily life intelligence, for problem solving, as we have now with the art of models, for self-reflection, for design intelligence, and for wisdom. Okay, in this case we can ask a number of questions before we start to use a model. What is the function of a model in which scenario? Which origins are going to be deputed and represented? What is considered and what is not considered? How we can characterize it? That comes down directly to the classical rhetorics frame or to the extended W*H frame we have been developing with Ajanta Danayake. It is now the question whether an instrument is adequate and dependability within the given utilization scenarios. What means purpose invariance? What means solution faithfulness? That means in this case we have now a number of questions we can ask and we can use as criteria for our theory of models. Then we can say, okay, fine, let's now start with our laziness. We use stereotypes for different disciplines. What is the category of model we are using? What kind of origins are considered? What kind of profile we have? What kind of utilization scenario we have? What is the cumulative practice, the adequacy, dependability, the basis, the grounding? That means in this case we can use these stereotypes for being lazy and reusing the deep model underneath. For instance, in this case we can also say we have some kind of theory, a theory of analogy, for instance. We say, okay, fine, we consider only the relevant properties of our origins and of our model, and we use now, and we state now to which extent what is relevant, what is in our focus is really shown. Then we can use as threshold value, and then we can use also some kind of evaluation for the degree of structural analogy, for the degree of qualitative analogy, for the degree of structural alignment, maybe also of qualitative alignment, or for functional alignment based on our functions. And in this case we could have some kind of treatment of analogy. And in this case we see that analogy has a number of specific cases, and one of them is of course to have a mapping, or maybe the heavy case is to have a homomorphism. Okay, then in this case we see now that the analogy is nothing else as an extension of the mapping property. Mapping is far too strict, we have seen in our examples already. It is also inadequate. We might have some kind of similarity based on metaphors. We have mental models that do not allow us to formulate even formal languages and ontologies or taxonomies or glossaries. And in this case, mapping is not really the right thing. Maybe we should turn back to the 3 analogies given by Platon, the analogy of the sun, the analogy of the cave, and the analogy of the line or the proportions. In this case we can also specify what is abstraction. And in this case we can have with this way a very specific understanding of a model. We can say, okay, fine, normally we are targeting on a general model and we are considering particular models, but this is a really hard thing. It would be far better to have some kind of generalization procedure that allows us also to invert this generalizations, and in this case we are considering generic models that can be specialized to the special case. And then we have the play between generalization and specialization, and we have a better treatment of abstraction. We go from a general model, or let's say we would like to have a general model in mind, but in reality we go with some kind of generic model. And then we consider specific models. That is a far simpler way to consider all these modeling stuff. Okay, we have a number in this case of very specific modeling approaches. Pattern recognition is nothing else as a specific form of modeling. Data mining is a specific form of modeling. Data science is a specific form of modeling. That means in this case we have now specific forms, specific modes, how we are using models, and in this case we can have a corresponding theory support, and the theory support for models must not be deduction or classical logical reasoning. It can be used for induction, abduction, and for non-monetizing reasoning. So we can now, for instance, define what is a pattern. A pattern is representing some origins in a proper form, and we can use this kind of understanding of a model for having a systematic theory of pattern development, pattern recognition, and pattern usage. Okay, let's now come down to some summary. Models are omnipresent in life, engineering, and daily life. That is a belief I hope you share after this lecture. And it is an essential part of our life. It is an essential dimension of our life. Models are used everywhere, in sciences, in engineering, in daily life. Some of the examples you see here on this screen: for easy explanation, for learning, for investigation, for economics, as a blueprint, for database development, for problem solving, as an exhibition model, or maybe as the first analog computer, like the clock of Antikythera. Models are therefore instruments that are going to be used, and the instrument being can be used as a demarcation for the model being of the thing. That means in this case we have now something that is based on Heidegger's work on things. Okay, finally, models are universal instruments. We have a modeling culture, we have modeling styles. Models 2.0, 3.0, 4.0 are somehow already on the horizon. And finally, I would like to call for an international model club. I would like to ask you to send a letter of intent to my email address at University of Kiel, and then we can collaborate for modeling. Thank you for listening to the talk. I hope you will participate in our modeling club, and I hope to see you soon in modeling conferences, to see your papers, to see your work on models, and to see how models are really used as an essential component of our life. Thanks.